Thank you, Nikunj, for sharing your insights on operational AI and the importance of incorporating domain expertise. Next, we have John Sobel, co-founder and CEO of Sight Machine. Take it away, John.
Hi, I'm John Sobel. I'm with Sight Machine. I'm one of the founders of our company and the CEO, and it's a privilege to join you all and to be part of SESME's discussion of AI for manufacturing. I'm going to very quickly share a point of view about what we believe is an important step for advancing AI, whatever the models or the use cases may be. And I'm going to do it by setting up some of the challenges that many of you in your companies are dealing with as you bring digital technology to the shop floor. Quickly, an overview. We've been doing Industry 4.0 for a decade now. The term was defined in 2011, and as many of you know, there was heavy investment in IoT, which we can think of as connectivity, starting 5 or 6 years ago. And then shortly afterwards, there was a lot of focus on AI, our topic today. But it's still really rare to find the fully enabled smart factory that's working the way everybody hoped would happen. And it's really useful to ask why. What's the problem? There's been over $200 billion a year being invested in digital transformation. If we look at productivity numbers in the United States, productivity has been flat for the last decade. All this investment hasn't really made any difference yet. From a sustainability point of view, we've made no appreciable dent in the effect on greenhouse gases or energy usage. Manufacturing is a huge contributor to those challenges. So we're spending money, we're investing a lot. A lot of companies are doing work around AI. It's not going nearly as fast as people hoped, and there's been quite a bit of confusion. What's the problem? This is where SESME's leadership strikes me individually as very thoughtful and very important. Most companies and most people who invested early in IoT and AI, in smart manufacturing, analogized what we're doing in factories to the IT world. And the belief was if we can get the data flowing and we can analyze it, we'll be in the world that's a lot like the world we're in with virtual world data. That's represented on the left of this slide. It's hard to read the words on the right side of the slide. I'm borrowing one of SESME's slides that I think is just wonderful to make this point. That stack of software is the typical manufacturing software stack. You literally find hundreds of pieces of software in the modern manufacturing enterprise. It's nothing like the IT stack on the left. Data's being generated continuously. Some is time series, some is batch. It's coming from different sources all over the plant. It's at different rhythms and different formats. And it's very hard to make any sense of it. We all know this. But when we step back and think about it, it's clear that this data in no way is ready for AI. Now, there's one other challenge that I'll just mention briefly, and that has to do with how people create AI. AI is often built through models. And what most people do is they build models of machines. That's the intuitively obvious thing to model when thinking about manufacturing. But pretty soon, because manufacturing has so many machines involved, just to make a simple product, you have hundreds or thousands of models. And getting all those models to talk to each other is very hard. This is an area of focus for SESME. It's an area of focus for all of us who are joining you today. We've got to find something in this messy, complicated environment that's standardized. And we believe at our company, and I think I'm probably very much in line with the other folks you're hearing from today, that standardization is important at the data level. Now, this has yet to be really figured out at an industry level. What exactly are we going to standardize around? What do we call it when we do this? And that's what I want to talk about with you in the balance of my time. There are several ways to represent manufacturing activity. We can build models of machines. We can build models of work. One way or another, we need to get data into consistent, relatable forms so that data from one person's plant or one person's line can be compared and contrasted to data from another person's plant or another person's line. And this may sound like a very simple concept. It's achievable. It's not easy, but it's something that everybody is focusing on, especially in the AI community. I recently looked over some of the literature that's coming out from the leading thinkers in AI, and they're all talking about it in 2021. This wasn't really a topic until this year. I've got up here on the slide a picture of a gentleman named Andrew Ng. He's one of the leading communicators about AI. And for the past couple months, he's been talking about moving from a model-centric world to a data-centric world, making sure that we focus on consistent, relatable, useful, good data for AI. This may seem so obvious, but for a long time, there's been excitement and enthusiasm about AI models and AI techniques, and not enough attention paid to getting the data right that goes into AI. One of the leading companies that developed a lot of AI, Google, has written about this at length. They came out with a paper this past summer. Everybody wants to do the model work, not the data work. And here's the introductory paragraph. Data is the critical infrastructure necessary to build artificial intelligence systems. Data largely determines performance, fairness, robustness, safety, and scalability of AI systems. Paradoxically, for AI researchers and developers, data is often the least incentivized aspect, viewed as operational relative to the lionized work of building novel models and algorithms. Intuitively, AI developers understand that data quality matters, often spending inordinate amounts of time on data tasks. In practice, most organizations fail to create or meet any data quality standards, from undervaluing data work vis-a-vis model development. So the community is realizing that to make any of this work, we got to have good data. Now, what does good data mean? Let's talk about ways we use data every day. We don't even think about standardization is operating in the background. And then let's compare it to industry. Say you run a large business with stores all over the world, and you want to know, where are my sales the highest? You may have different systems. You may have a bunch of Excel floating all around your company, but sooner or later, you're going to be able to answer that question, because even if different stores and locations track sales in different currencies, eventually they're going to put everything into dollars. And you can look at who's making the most dollars. There is a relatable common unit in the data around money. If we want to apply AI and start predicting which stores are going to do the best, we can run all kinds of cool models and algorithms on that. Underneath it, the data is structured around the concept of money, so the AI is going to work. In industry, we're applying AI to things like predictive maintenance. When's a machine going to fail? And if we're studying one machine, we can build a model around some unit that's going to be useful for that model as far as that machine is concerned. It might be machine failures. It might be the work that the machine does every hour. Whatever we do is probably going to work pretty well for one machine. But now let's think about what SESME is really focusing on, the industry level here. We want to understand all the machines and all the plants in the North American supply chain. We should be able to do that. There's 5,000 plants in North America. There's tons of machines. There's tons of data. We got plenty of computing to handle it. But we don't have a way to relate all of the data in this world to the other data in this world. And that's the next frontier of all this work. Now, over the next couple of years, there's going to be a lot of healthy dialogue and debate. What are the right units? What are the right ways to make this all relatable? And when we figure that out, that's how we're going to unlock all the opportunity of the AI that people are talking about. I'll share quickly some perspective from our company. We're a data platform. Our company was founded 10 years ago. We were founded by a bunch of people who came from internet and big data, who also come from manufacturing. And we've been thinking about this for a decade. And we have really started to work closely with SESME and others around this notion of standardization. This is a picture of a plant that we work in. We happen to do 20 or 25 of these plants for this company. And when I say we happen to do work at these plants, what I mean is we're streaming data out of them continuously, and there's tens of thousands of data sources in each of these plants. This is a paper mill. If you think for a moment about the types of assets that are involved in running a paper mill, they're all very different. We and others who you're hearing from today are all thinking about how do we standardize the data from these different systems. And this is a simplified schematic of the type of work that we do. We actually use the same data structures and data models to represent the behavior of every asset, every process in this system, and every asset and every process and every system we study. I think we're at the beginning of a real transition in the industry. There's been so much development of good models. I'll just give you a Cook's tour of the kind of models that we use at our company. Gradient boosted decision trees, support vector machines, genetic algorithms, GLM regression, functional data analysis, NLP, agglomerative clustering. I don't know what most of this stuff means. Our data scientists do. But all of it is driven by the same data foundation, the same standardized data. We could probably do 25 more AI techniques on this because we've got the data right. And with the leadership that John and everybody at SESME are bringing to this discussion, I think that's what's going to happen for the industry. Thanks so much for having us join you today. It's a privilege. Thank you.